You think you see the world in full color. You believe your eyes capture reality exactly as it exists. But what if I told you that you're living inside the most elegant prison ever designed? A prison built not by bars or walls, but by the very biology that gives you sight? What if the rainbow you've known your entire life is nothing more than a tiny sliver of an infinite spectrum that surrounds you every moment of every day? Your brain has been lying to you, not maliciously, not deliberately, but systematically and completely. Every sunset you've marveled at, every flower you've admired, every painting that's moved you to tears, you've been seeing them through the narrow window of a biological cage that evolution built around your consciousness 300 million years ago. The most disturbing part? You were born into this prison, raised in it, and you've never known anything else exists beyond its walls, until now. The three-color conspiracy deep inside your eye right now sits the most sophisticated deception in human biology. 3 types of cells, just 3, are responsible for everything you call color. Think about that for a moment. Your entire visual universe, every shade and hue you've ever experienced, every color that's ever made you gasp in wonder, all of it comes from just 3 different types of light detectors. These cells, called cones, are evolutionary survivors of an ancient biological arms race. The first one responds to what we call red light, though it's actually more sensitive to yellow-green wavelengths than true red. The second detects green, but its sensitivity curve overlaps so much with the red detector that the distinction becomes blurrier than you might imagine. The third responds to blue, but it's the weakest of the 3, easily overwhelmed by its more dominant partners. But here's where the conspiracy deepens. These 3 cone types didn't evolve to show you beauty. They evolved for one purpose only: survival. Your ancestors needed to spot ripe fruit against green leaves. They needed to detect the flush of health or pallor of sickness in potential mates. They needed to see predators lurking in shadows and prey hiding in tall grass. Your color vision is a survival tool masquerading as an aesthetic experience. Every color you see is actually your brain's interpretation of how these 3 primitive detectors respond to different wavelengths of light. When red and green cones fire together in specific proportions, you experience yellow, even though there might not be a single wavelength of yellow light entering your eye. When all 3 fire at once, you see white, even though white isn't really a color at all. Your brain takes these 3 simple signals and constructs an entire world of color from them. It's like trying to paint the Mona Lisa using only 3 brushes. The result might be beautiful, but it's also fundamentally limited by the tools at your disposal. But evolution didn't stop there. It added another layer to this deception. Your brain doesn't just detect these 3 signals, it compares them against each other, creating what scientists call opponent color processing. Red opposes green, blue opposes yellow. This opposition isn't just a quirk of biology, it's the foundation of every color you've ever seen. This system works so well, feels so complete, that you never question it. The sky looks blue, roses look red, grass looks green, and everything seems perfectly natural. But you're seeing only the colors that helped your ancestors survive. You're trapped in a survival-based color system that's disguised itself as reality itself. Prisoners who don't know they're trapped. The most perfect prison is one where the inmates don't realize they're confined. You walk through life completely unaware that your color vision is actually a narrow window into a vast electromagnetic spectrum. You see wavelengths from about 380 to 700 nanometers, a tiny slice of the energy that constantly bathes our world. To understand just how narrow this window is, imagine the entire electromagnetic spectrum as a piano keyboard stretching from here to the moon. Your visible light, everything you can see, would be equivalent to a single key somewhere in the middle of that cosmic keyboard. One key. That's all you get. But your brain doesn't tell you this. Instead, it takes that single key and creates what feels like a complete symphony of color. It fills in gaps, makes assumptions, and presents you with a seamless experience that feels whole and complete. Your visual system is so convincing that it never occurs to you to question what you might be missing. This isn't just about missing a few extra colors. You're missing entire categories of visual information that other creatures consider essential. The thermal signatures that guide heat-seeking predators. The polarization patterns that help insects navigate. The ultraviolet markings that transform flowers into landing strips only bees can see. Your color vision is like reading a book where 99% of the pages have been torn out, but the remaining pages flow so smoothly that you never notice the gaps. Your brain is such a skilled editor that it makes the incomplete seem complete, the limited seem infinite. Consider this: every color word in every language humans have ever spoken refers to combinations of just those three cone responses in your eye. When ancient peoples named colors, when poets crafted verses about crimson sunsets and azure skies, when artists mixed pigments to capture the perfect shade, all of it was limited by the same three-detector system you possess right now. We've built entire industries around this limitation. Fashion, interior design, graphic arts, film, photography, all of it designed for eyes that can only detect three primary wavelengths. We've convinced ourselves that red, green and blue are fundamental properties of reality, when they're actually just the boundaries of our biological prison. The most tragic part is how completely this system has shaped human culture. We associate colors with emotions, with meanings, with memories, but all of these associations are based on the narrow range of wavelengths our ancestors could detect. We've created poetry about colors we can see, while remaining forever silent about the colors we cannot. The invisible rainbow, all around you right now, colors are dancing that you'll never see. They're reflecting off every surface, emanating from every light source, painting the world in hues so vivid and distinct that if you could perceive them for just one moment, the colors you've always known would seem pale and lifeless by comparison. The flower sitting on your windowsill isn't just yellow and green. It's blazing with ultraviolet patterns so intricate and beautiful that they make human art look crude by comparison. These patterns guide bees with precision that GPS systems envy, creating landing strips and directional arrows invisible to your imprisoned eyes. The flower has been trying to show you its true beauty your entire life, but you lack the biological equipment to receive its message. Your warm coffee mug is glowing. Right now it's emanating infrared radiation in patterns that shift and flow with each degree of temperature change. It's painting thermal landscapes across your kitchen that tell stories of heat flow, energy transfer, and molecular motion. To creatures that can see infrared, your morning routine becomes a light show of moving, breathing, glowing forms. The sky above you isn't just blue, it's streaked with polarization patterns that create highways only certain animals can follow. These patterns shift with the sun's position, creating a celestial compass so precise that it works even on cloudy days. Migrating birds navigate using road signs written in light that you walk beneath without ever seeing. Even the walls of your room are reflecting wavelengths you cannot perceive. Infrared signatures reveal which areas are warm and which are cool. Ultraviolet reflectance creates patterns based on the molecular structure of paint and wallpaper. What looks like a solid color to you might be a complex tapestry of different wavelengths to eyes capable of broader perception. Your own body is constantly broadcasting in frequencies you cannot see. Your heat signature creates a glowing outline that changes with your emotions, your health, your level of activity. You're literally radiating information about your internal state, but you're blind to your own light show. This invisible spectrum isn't empty or random. It's full of information, beauty, and meaning that other creatures consider essential to their lives. Reindeer use ultraviolet vision to spot predators against snowy backgrounds. Snakes detect the infrared glow of warm-blooded prey in complete darkness. Bees see landing patterns on flowers that are completely invisible to the humans who planted those same flowers. The most humbling realization is that this isn't a flaw in your vision. It's working exactly as evolution designed it. Your three-cone system is perfectly adequate for human survival, but adequacy and completeness are very different things. You've been living your entire life in a world far more colorful, far more complex, and far more beautiful than your eyes will ever be able to reveal. Every sunset you've watched was more magnificent than you could see. Every rainbow contained colors that don't exist in your vocabulary. Every flower in every garden has been trying to show you beauty that your eyes simply cannot detect. The question that should haunt you now is this: if you're blind to so much of the spectrum that surrounds you every day, what other aspects of reality are you missing? What else is your brain editing out, filling in, or simply failing to detect? How much of what you think you know about the world is actually just the limited perspective of a consciousness trapped inside a biological system designed for survival, not truth? You are not seeing reality. You are seeing a survival-filtered, biologically edited, three-wavelength approximation of reality. And until you acknowledge this limitation, you remain a prisoner of your own perception, trapped in a beautiful cage you don't even know exists. The prison walls are invisible because they're built from the very mechanism you use to see. Your eyes are both the window to the world and the bars that keep you from seeing it clearly. You are simultaneously the prisoner and the guard, the captive and the captor, forever bound by the biological system that promises to show you everything while revealing almost nothing at all. Chapter 1. The 16-Color God. The human eye is a marvel of evolution, finely tuned over millions of years to detect three primary colors that helped our ancestors survive in an ancient world. But deep beneath the ocean's surface, nature has created something that makes our vision look primitive by comparison, something that challenges everything we thought we knew about seeing color. What you're about to discover lives in the coral reefs of the Indo-Pacific, and it possesses the most sophisticated color vision system on Earth. This creature doesn't just see the world differently than we do, it sees a world that we cannot even begin to comprehend. The mantis shrimp has 16 different types of color receptors in its eyes compared to our 3. That's not just a little better. That's a complete transformation of what it means to see. The alien among us. Every second of every day, you are surrounded by colors that remain completely invisible to your eyes. The flower in your garden, the shirt you're wearing, even your own skin, they're all reflecting wavelengths of light that your brain simply cannot process. You're living in a world where the majority of colours are hidden from you, and you don't even know it. The mantis shrimp lives in that hidden world. When a mantis shrimp looks at what you see as a simple piece of coral, it sees patterns, gradients and hues that would overwhelm your brain if you could perceive them. Imagine looking at a sunset and seeing not just the reds, oranges and yellows that you know, but 12 additional colours that you have no names for, no reference points for, no way to even imagine. This isn't science fiction. This is the daily reality of the mantis shrimp. Marine biologist Dr. James Liu has spent the last 15 years studying these creatures, and his research has revealed something that fundamentally challenges our understanding of perception itself. The mantis shrimp doesn't just see more colours than we do, it sees colours that exist in spectrums we didn't even know were possible. Think about this carefully. When you look at a rainbow, you see 7 distinct bands of colour. But a mantis shrimp looking at that same rainbow would see dozens of additional bands, each one as distinct and vivid to them as red is to you. They're seeing the same physical phenomenon, but their experience of it is so vastly different that it might as well be a completely different rainbow. The most remarkable part of this discovery is that the mantis shrimp's colour vision isn't just better than ours, it operates on completely different principles. While our eyes blend 3 primary colours to create all the hues we can see, the mantis shrimp's eyes analyse each wavelength of light independently. They don't need to blend or combine colours to see new ones. They simply see each colour as it truly exists in the electromagnetic spectrum. This means that colours which appear identical to us, like 2 different shades of red that look exactly the same to your eyes, are as obviously different to a mantis shrimp as red and blue are to you. They're living in a world where what we call similar colours are actually wildly different. And what we call the same colour might actually be dozens of completely distinct hues. The poetry of impossibility language shapes the way we think about colour in ways that are both profound and limiting. You have words for red, blue, green, yellow, but what happens when you need to describe a colour that doesn't fit into any of these categories? What happens when you encounter a colour that violates the very rules that govern how colours are supposed to work? Poet and philosopher Dr. Elena Vasquez has dedicated her career to exploring this exact question. She's attempting something that most people would consider impossible, creating language for colours that don't exist in human experience. Her work reveals just how much our language imprisons our ability to think about colour. Consider the word purple. In your mind, purple is a specific thing. It's the colour you get when you mix red and blue. But Dr. Vasquez has coined a new term, verpal. Verpal isn't just a different shade of purple. It's a colour that combines violet and purple in a way that transcends both. It's a colour that exists in the mathematical space between wavelengths, a colour that could theoretically exist but that your brain is fundamentally incapable of processing. The challenge of describing verpal reveals something profound about the relationship between language and perception. You can understand the concept of verpal intellectually. You can think about it, discuss it, even write equations to describe it. But you cannot see it, and more importantly, you cannot truly understand it in the way that understanding requires actual experience. Dr. Vasquez has created an entire vocabulary of impossible colours. There's gred, a color that combines green and red in a way that violates opponent color theory. There's yellow, a simultaneous experience of yellow and blue that should cancel each other out, but instead create something entirely new. These aren't just creative names for existing colors. They're linguistic attempts to describe colors that exist in mathematical reality, but not in human experience. The poetry of impossible colors goes beyond mere description. When Dr. Vasquez writes about Virpil, she's not just trying to help you imagine a new color, she's trying to expand the very capacity of human consciousness to conceive of new forms of beauty. Her work suggests that the limits of our language directly limit our ability to perceive reality. This linguistic limitation has profound implications. If you don't have words for the colors that a mantis shrimp can see, can you even think about them coherently? If your language is built around the assumption that colors come in complementary pairs, red and green, blue and yellow, how can you even begin to conceptualize a color that combines these opposites? The answer is both humbling and exciting. Dr. Vasquez's work suggests that expanding our vocabulary for impossible colors might actually be the first step toward expanding our ability to perceive them. Language doesn't just describe reality. It shapes our capacity to experience reality. The simulation paradox. The question of whether we can truly understand something we cannot experience lies at the heart of computer scientist Dr. Raj Patel's groundbreaking work. For the past decade, he's been attempting something that sounds simple but is actually extraordinarily complex, creating a computer display that can show us what the world looks like through a mantis shrimp's eyes. The challenge isn't just technical, it's fundamental. How do you display colors that don't exist in human experience on a screen that was designed for human eyes? How do you show someone a color that their brain is literally incapable of processing? Dr. Patel's solution is elegant and deeply unsettling. He's created displays that can stimulate your visual system in ways that nature never intended. The screens that Dr. Patel has developed don't just show different colors, they show impossible colors. They're designed to present your eyes with combinations of wavelengths that shouldn't work together, colors that violate the basic principles of how human color vision operates. When you look at these displays, your brain receives information that it cannot properly process. The experience of looking at Dr. Patel's impossible color displays is unlike anything you've ever encountered. Your eyes receive the information, but your brain struggles to make sense of it. People describe feeling nauseated, disoriented, or overwhelmed. Some report seeing colors that seem to shift and change as they look at them, colors that their brain keeps trying to categorize but can't quite pin down. This isn't just a technical curiosity, it's a window into the fundamental nature of perception itself. Dr. Patel's displays reveal that the difference between possible and impossible colors isn't about physics. It's about the limitations of your neural processing. The colors exist in the electromagnetic spectrum, but your brain simply isn't equipped to perceive them. The paradox of the simulation is this. Dr. Patel can mathematically calculate exactly what a mantis shrimp sees when it looks at any given object. He can create precise models of how their 16 color receptors would respond to different wavelengths of light. He can even display approximations of these colors on his specialized screens. But he can never actually show you what the mantis shrimp sees, because you don't have the neural architecture to process that information. This limitation reveals something profound about the nature of consciousness and experience. There are aspects of reality that exist that can be measured and calculated and understood intellectually, but that remain forever beyond human experience. The mantis shrimp's color vision isn't just different from ours, it's fundamentally inaccessible to us. Dr. Patel's work has led him to a startling conclusion. The mantis shrimp might be living in a richer, more beautiful world than we can possibly imagine. Every coral reef, every school of fish, every ray of sunlight filtering through the water, all of these things might be vastly more complex and beautiful than we realize, filled with colors and patterns that our limited vision simply filters out. The implications of this realization extend far beyond color vision. If there are aspects of visual reality that remain hidden from us, what else might we be missing? What other dimensions of experience might exist that we don't even know to look for? The mantis shrimp has revealed something that fundamentally challenges our understanding of perception and reality. We are not passive observers of the world around us. We are active participants in creating our experience of that world through the limitations of our sensory systems. The colors we see, the reality we experience, the beauty we perceive, all of these things are filtered through the constraints of our biology. But the story of impossible colors doesn't end with the mantis shrimp. While nature has created creatures with expanded color vision, human beings have begun to develop our own methods for breaking free from the limitations of our evolutionary inheritance. Scientists have discovered that under very specific conditions, it's actually possible to make human beings see colors that shouldn't exist. The question that emerges from this discovery is both thrilling and unsettling. If we can see impossible colors, what does that tell us about the nature of color itself? And more importantly, what does it tell us about the nature of human consciousness and our ability to perceive reality? The boundary between possible and impossible is about to become much more complex than we ever imagined. Chapter 2. The Forbidden Colors. Your brain is lying to you, not maliciously, not intentionally, but consistently and completely. Every single day, it tells you that certain combinations of colors simply cannot exist. Red and green together? Impossible. Blue and yellow simultaneously? Your neural wiring won't allow it. But what if I told you that scientists have found a way to break these rules, to force human beings to see colors that shouldn't exist, according to everything we know about vision and perception? The colors I'm talking about aren't just rare or unusual. They're what researchers call impossible colors or forbidden colors. And they represent one of the most fascinating frontiers in neuroscience and human perception. These aren't theoretical constructs or mathematical abstractions. Real people in real laboratories have actually seen them, and their reactions suggest we've been living in a much smaller, much more limited visual world than we ever imagined. To understand how scientists accomplished this seemingly impossible feat, we need to dive deep into the machinery of your visual system. Your brain processes color through what neuroscientists call opponent color theory, and this system has been both your greatest gift and your most restrictive prison when it comes to perceiving the full spectrum of reality. The opponent color wars. Think of your brain as running an ancient ongoing war between opposing color armies. In one corner, you have red fighting against green. In the opposite corner, blue battles yellow. This isn't a metaphor or a simplification. This is literally how your visual cortex processes every single photon that enters your eye. When light hits your retina, your cone cells, The specialized neurons responsible for color vision begin firing signals to your brain. But here's where it gets fascinating. Your brain doesn't simply record these signals as individual pieces of information. Instead, it immediately begins comparing them, creating what neuroscientists call opponent processes. Your red-green opponent channel works by taking the signal from your long wavelength cone cells, the ones that respond to reddish light, and subtracting the signal from your medium wavelength cone cells, the ones that respond to greenish light. When red signals dominate, you perceive redness. When green signals dominate, you perceive greenness. But here's the crucial point. According to this system, you cannot perceive both simultaneously. The very architecture of your visual processing makes reddish-green a neurological impossibility. The same principle applies to your blue-yellow opponent channel. Your brain takes signals from your short wavelength cone cells, sensitive to bluish light, and compares them with a combination of signals from your other cone types. The result is that you can see blue, you can see yellow, but you cannot see bluish yellow. Your brain's wiring simply won't allow it. This opponent color system evolved for excellent reasons. It allows your visual system to extract maximum information from limited neural resources. Instead of your brain having to process and store information about every possible wavelength combination, it can efficiently code color information using just these opponent channels. It's an elegant solution that served our ancestors well as they navigated environments where distinguishing ripe fruit from unripe fruit, or healthy vegetation from diseased vegetation, could mean the difference between survival and starvation. But evolution's elegant solution comes with a hidden cost. By organizing color processing around these opponent relationships, your brain has created what researchers call forbidden zones in color space. These are combinations of neural signals that your visual system actively prevents you from experiencing. When light that should theoretically produce a reddish-green sensation enters your eye, your brain's opponent processing immediately resolves the conflict by pushing your perception toward either red or green, never both. Neuroscientist Dr. Sarah Chen has spent the better part of a decade studying these opponent processes, and she describes the situation with remarkable clarity. Imagine you have two people in a room and they're programmed to never speak at the same time. If one starts talking, the other must immediately fall silent. That's essentially what's happening in your brain with red and green signals, with blue and yellow signals. The system is designed to prevent simultaneous activation, which means there are entire regions of possible color experience that remain forever locked away from normal human perception. This raises a profound question that cuts to the heart of human consciousness and perception. If your brain is actively preventing you from seeing certain colors, what else might you be missing? How much of reality is filtered out, processed away, or simply ignored by the biological machinery of perception? The mathematical implications are staggering. Color scientists can map every possible color that human vision can theoretically distinguish, creating what they call a color gamut or color space. But when you account for opponent color processing, vast regions of this theoretical color space become inaccessible. It's as if you're living in a house where entire rooms have been permanently locked, and you've never even realized they exist. But the story becomes even more intriguing when you consider that these opponent processes aren't just theoretical constructs, they're measurable, observable phenomena. Using sophisticated brain imaging techniques, researchers can actually watch opponent color processing happening in real time. They can see the neural competition between red and green signals, between blue and yellow signals, playing out in the visual cortex as your brain actively constructs your perception of color. This is where the science becomes almost philosophical. Your experience of color isn't a passive recording of the wavelengths entering your eye. It's an active construction, a neural interpretation that involves competition, suppression, and the systematic elimination of certain possibilities. Every color you've ever seen represents not just what was present in the light, but what your brain allowed you to perceive after processing that light through its opponent color machinery. The stabilized image revelation. Scientists are remarkably creative when it comes to breaking rules, especially rules imposed by biology. In the 1980s, researchers began asking a deceptively simple question. What would happen if we could somehow bypass or overwhelm the opponent color processing that prevents us from seeing impossible colors? The answer led to one of the most extraordinary discoveries in the history of vision research. The breakthrough came through understanding a quirky feature of human vision called saccadic masking. Your eyes are constantly moving in tiny, involuntary jumps called saccades, typically occurring 3 to 4 times per second. These movements serve a crucial function. They prevent your photoreceptors from adapting to constant stimulation, which would cause images to fade from view. But researchers realized that these constant eye movements also play a role in maintaining opponent color processing. Dr. Hewitt Crane and Dr. Thomas Piantanida, working at SRI International, developed an ingenious solution. They created a system that could track eye movements in real time and adjust displayed images to compensate for those movements. This technique, called image stabilization, essentially locks an image onto specific parts of your retina, regardless of where your eyes move. Using this stabilized image system, the researchers created displays showing adjacent fields of red and green or blue and yellow. Under normal viewing conditions, your eyes would constantly move, allowing your opponent color processing to maintain its normal function of preventing simultaneous red-green or blue-yellow perception. But with the images locked onto your retina, something extraordinary happened. Test subjects reported seeing colors they had never experienced before and struggled to describe. When viewing the stabilized red-green display, participants didn't see red, they didn't see green, and they didn't see some intermediate color like orange or brown. Instead, they reported seeing a color that was simultaneously red and green, a color that seemed to contain the full essence of both redness and greenness without compromising either quality. The experience was so unusual that researchers had to develop entirely new methods for documenting what subjects were seeing. Traditional color-matching experiments, where subjects try to recreate colors they've seen using combinations of other colors, simply didn't work. How do you match a color that cannot be created through any combination of normal colors? Dr. Vincent Billock, a vision researcher who has extensively studied these phenomena, describes the experience of viewing impossible colors as fundamentally different from normal color perception. When subjects see these impossible colors, they're not just seeing something new. They're experiencing a completely different category of visual sensation. Their descriptions often include phrases like reddish-green or bluish-yellow, but they emphasize that these aren't mixtures or intermediates. They're seeing colours that maintain the full perceptual impact of both opponent colours simultaneously. The implications of these experiments extend far beyond academic curiosity. They demonstrate that the limitations of human colour vision aren't necessarily permanent or insurmountable. The machinery for processing impossible colours exists within your visual system. It's simply being suppressed by higher-level processing mechanisms that evolved for different purposes. But perhaps most remarkably, subjects who have experienced impossible colours report that the experience changes their understanding of colour permanently. Many describe feeling that normal colours seem somehow impoverished or incomplete after experiencing the full perceptual richness of impossible colours. It's as if they've glimpsed a more complete version of reality and found it difficult to accept the limitations they previously never noticed. The stabilized image experiments also revealed something unexpected about the nature of consciousness and perception. When viewing impossible colors, subjects often report that the colors seem to shimmer or fluctuate, as if their brain is actively fighting against the experience. This suggests that opponent color processing isn't just a passive feature of your visual system. It's an active, ongoing process that your brain must constantly maintain to preserve normal color perception. These experiments opened up entirely new questions about the nature of human perception. If impossible colors can be perceived under certain conditions, what other aspects of reality might be accessible to human consciousness but normally suppressed by our biological processing systems? The research suggests that the boundaries of human perception might be far more flexible than we previously imagined. Moreover, the success of these experiments provided crucial proof that impossible colors aren't just theoretical constructs or mathematical abstractions. They're real perceptual experiences that can be accessed by human consciousness under the right conditions. This distinction is crucial because it moves impossible colors from the realm of philosophical speculation into the domain of empirical neuroscience. The tetrachromat among us. Jennifer Walsh lives in a world that might be unimaginably richer than yours. While you navigate reality with 3 types of color-detecting cone cells in your retina, Jennifer may possess a 4th type, making her what scientists call a tetrachromat. If this is true, and the evidence suggests it might be, then Jennifer's visual experience could include millions of colors that remain completely invisible to the rest of humanity. Tetrachromacy isn't science fiction. It's a well-documented genetic variation that occurs naturally in humans, though it's quite rare. The condition results from having an additional type of cone cell with a different sensitivity profile than the standard 3 types found in normal human vision. While most people are trichromats with cone cells sensitive to roughly red, green and blue wavelengths, tetrachromats possess a 4th cone type that typically falls somewhere between the red and green sensitivities. The mathematics of tetrachromatic vision are staggering. Normal human vision can distinguish approximately 10 million different colors. This might sound impressive, but it's actually quite limited compared to what's theoretically possible. Each additional type of cone cell doesn't just add more colors, it multiplies the possibilities exponentially. A tetrachromat with optimally spaced cone sensitivities could potentially distinguish over 100 million different colors. But identifying tetrachromats presents extraordinary challenges for researchers. How do you test whether someone can see colors you can't see? How do you measure perceptual experiences that may be completely outside the range of normal human consciousness? Dr. Gabriele Jordan at Newcastle University has developed sophisticated testing procedures specifically designed to identify potential tetrachromats. Her tests involve displaying color combinations that should appear identical to normal trichromatic vision, but might appear distinctly different to tetrachromatic vision. The process requires incredible precision because the differences being measured exist in regions of color space where normal human vision shows little to no sensitivity. Jennifer Walsh was identified as a potential tetrachromat through exactly these kinds of tests. When presented with color samples that appear virtually identical to trichromatic observers, Jennifer consistently demonstrates the ability to distinguish between them. She can point to differences in hue, saturation and brightness that remain completely invisible to researchers and other test subjects. But perhaps most fascinating are Jennifer's descriptions of her daily visual experience. She describes seeing subtle color variations in objects that appear uniform to others. A white wall might contain dozens of different hues that she perceives as obviously distinct, but that remain completely invisible to everyone around her. Red roses contain gradations of color that she can point to, but cannot adequately describe, because the language of color was developed by and for trichromatic vision. The isolation of tetrachromatic experience creates profound communication challenges. Jennifer often finds herself frustrated when trying to describe what she sees because human color vocabulary was developed around trichromatic perception. Terms like red, green, and blue are inadequate for describing colors that fall outside normal human experience. It's as if she's trying to describe a symphony to people who can only hear 3 notes. Dr. Kimberly Jameson, who studies individual differences in color perception, explains the situation with remarkable insight. Imagine trying to describe the color red to someone who has never seen color at all. That's essentially the challenge facing tetrachromats when they try to communicate their visual experience to trichromats. They're perceiving aspects of reality that the rest of us simply cannot access, and our shared language has no terms for these experiences. But tetrachromacy raises profound questions about the nature of reality and perception. If Jennifer's visual experience is dramatically richer than normal human vision, which version represents the true colors of objects in the world? Are the additional colors she perceives actually present in the light reflecting from objects, or are they artifacts of her unusual visual processing? The answer appears to be that the additional colors are genuinely present in the physical world. Objects do reflect complex combinations of wavelengths that contain information invisible to normal human vision. Tetrachromats like Jennifer aren't seeing things that aren't there. They're seeing things that are there, but normally invisible to human perception. This realization has profound implications for how we understand human knowledge and scientific observation. Throughout history, humans have used technological instruments to extend our perceptual capabilities. Telescopes to see distant objects, microscopes to see tiny structures, spectrometers to analyze the composition of light. But tetrachromacy suggests that some humans naturally possess extended perceptual capabilities that reveal aspects of reality hidden from the majority of our species. The existence of natural tetrachromats also provides crucial insights into the plasticity and potential of human perception. If genetic variations can produce dramatically enhanced color vision, this suggests that the limitations of normal human perception aren't necessarily fixed or permanent. Understanding how tetrachromatic vision works could potentially lead to methods for enhancing normal human color perception through technology or training. Perhaps most intriguingly, tetrachromacy demonstrates that impossible colors might not be impossible for everyone. While normal trichromatic vision cannot perceive reddish-green or bluish-yellow because of opponent color processing, tetrachromatic vision, with its additional cone type, might be able to process color combinations that remain forbidden to normal human perception. Jennifer Walsh represents a living bridge between the limited color world most humans inhabit and the vastly richer perceptual reality that might be possible for human consciousness. Her existence proves that the boundaries of human perception are not as fixed as we might assume, and suggests that there are aspects of reality waiting to be discovered by eyes capable of seeing them. When Jennifer looks at the world around her, she sees beauty and complexity that remain invisible to almost everyone else. Her experience suggests that reality itself might be far more colorful, far more rich and far more magnificent than most human beings will ever know. And that raises the ultimate question: in a universe full of colors we cannot see, what else might we be missing? Chapter 3. The Color Hackers. Every single day you wake up believing you see the world in full color. But what if I told you that you're actually living in a black and white movie, and you just don't know it? What if the vibrant rainbow you think you're experiencing is nothing more than a pale shadow of reality? Here's something that will blow your mind. There are people walking among us who see colors that you literally cannot imagine, not metaphorically, not poetically, literally. Colors that would make your current vision seem like looking at the world through frosted glass. And the most shocking part? Scientists have figured out how to give these superpowers to anyone, including you. The technology exists right now, today. While you're watching this video, there are researchers in laboratories across the world who have successfully expanded human color vision beyond what evolution gave us. They've broken the biological barriers that have limited our species for hundreds of thousands of years. And what they've discovered will change everything you think you know about seeing. But here's the catch that nobody talks about. These color hackers have uncovered something that governments and corporations don't want you to know. The technology to enhance your vision isn't just about seeing prettier sunsets. It's about perceiving reality itself in ways that could fundamentally alter human consciousness. And some of these researchers are starting to question whether we should be messing with human perception at all. The Enchroma Revolution. Let me tell you about a moment that breaks people's brains every single day. There's a pair of glasses sitting in a laboratory right now that can instantly give you access to millions of colors you've never seen before. These aren't science fiction. They're called Enchroma glasses, and they're performing miracles that would have been considered magic just 50 years ago. But here's what the marketing doesn't tell you. These glasses don't just help colorblind people see red and green. They're accidentally revealing something much more profound about how all of us see color. Something that's making scientists completely rethink what human vision is capable of. When a colorblind person puts on Enchroma glasses for the first time, something extraordinary happens in their brain. The neural pathways that have been dormant their entire lives suddenly light up like a Christmas tree. But neuroscientists studying these reactions discovered something nobody expected. The brain doesn't just start processing the colors it was missing. It starts creating entirely new color experiences that don't exist in nature. Think about this for a second. A person who has lived 40 years seeing the world in limited colors suddenly has access to color combinations that their brain has never encountered. And their brain doesn't just passively receive this information, it actively starts generating new color perceptions by combining signals in ways that have never happened before in human history. Dr. Elena Martinez, the lead researcher studying enchroma effects, made a discovery that kept her awake for weeks. When she monitored the brain activity of people using these glasses, she found neural patterns that didn't match any known color processing mechanisms. The subjects were seeing colors that technically shouldn't exist, according to everything we know about human vision. Their brains were essentially hallucinating new colors into existence. But here's where it gets really weird. Some of these people started reporting that they could still see these impossible colors even after taking the glasses off. Their brains had been rewired permanently. They had been given access to a larger color space, and their neural networks refused to give it up. The implications are staggering. If simple glasses can unlock dormant color processing abilities in colorblind individuals, what could more advanced technology do for people with normal vision? What if everyone is actually colorblind compared to what human vision could potentially achieve? The cyborg solution. Now, let me introduce you to someone who has completely abandoned the idea that humans should be limited by biology. Neil Harbison looks like an ordinary person, except for one small detail. He has an antenna surgically implanted in his skull that allows him to hear colors that don't exist in human visual experience. This isn't a metaphor. Harbison's antenna detects electromagnetic frequencies far beyond what human eyes can perceive, and it converts them into audible tones that his brain has learned to interpret as colors. He can literally hear the color of radio waves, infrared radiation, and ultraviolet light. Colors that no human has ever seen, he experiences as a symphony of sounds that his brain translates into visual experiences. But here's what makes this absolutely mind-bending. Harbison's brain has adapted to this technology in ways that neuroscientists are still trying to understand. After years of training, he stopped hearing the sounds and started directly perceiving the colors. His auditory cortex somehow learned to generate visual experiences from electromagnetic data. He had essentially grown a new sense organ. The breakthrough came when Harbison realized he could perceive colors from outer space. His antenna can detect electromagnetic signatures from distant galaxies, and his brain interprets these as colors that exist nowhere on Earth. He describes seeing the color of Saturn's rings, the hue of solar wind, and the chromatic signature of cosmic background radiation. He is literally the first human being to perceive the colors of the universe beyond our planet. But Harbison's story reveals something terrifying about the future of human enhancement. He's no longer fully human in the traditional sense. His perception of reality is so fundamentally different from ours that he struggles to communicate his experiences. He sees colors in everything around him that are completely invisible to everyone else. He has become isolated in a world of impossible beauty that he can never fully share. This raises a question that keeps bioethicists awake at night. If we can technologically expand human senses beyond biological limits, at what point do we stop being human? Harbison's brain has been so fundamentally altered by his technology that he processes reality in ways that are completely alien to our species. He has become something new, something that might be better than human, but is definitely no longer human. The neural interface dream. Everything I've told you so far is just the beginning. Deep in a classified research facility, Dr. Amanda Foster has developed technology that makes Enchroma glasses and Harbison's antenna look like children's toys. She has created a brain-computer interface that can directly stimulate the visual cortex to produce any color experience imaginable, including colors that are mathematically impossible according to human biology. The technology works by bypassing the eyes completely. Electrodes placed on specific regions of the brain can trigger neural activity that creates color experiences without any light entering the visual system. But Dr. Foster discovered something that changed everything. When she stimulated combinations of neurons that should be impossible to activate simultaneously, volunteers reported seeing colors that broke their understanding of what color could be. One test subject described seeing a color that was simultaneously red and green, but wasn't yellow or any blend of red and green. It was purely red and purely green at the same time, existing in a visual space that shouldn't be possible. Another volunteer reported experiencing a color that had depth and movement, as if the color itself was alive and shifting through dimensions that don't exist in normal visual experience. But here's what's truly revolutionary about Dr. Foster's work. She's not just creating impossible colors, she's expanding the fundamental structure of human consciousness. The volunteers who experience these impossible colors report that their entire understanding of reality changes. They start perceiving depth, texture, and meaning in colors that goes far beyond anything they experienced with normal vision. Dr. Foster's brain scans reveal something extraordinary happening in these volunteers. The impossible color experiences trigger activity in brain regions that are normally associated with memory, emotion, and even spiritual experiences. Seeing impossible colors doesn't just change how people see. It changes how they think, feel, and understand their place in the universe. One volunteer, after experiencing what she called the color of consciousness itself, reported that she could no longer look at the world the same way. Colors that had seemed vibrant before now appeared dull and lifeless. She had been given a glimpse of a reality so much richer than normal human experience that returning to ordinary vision felt like a kind of blindness. But Dr. Foster's research has uncovered something that makes her question whether this technology should ever be released to the public. The volunteers who experience impossible colors consistently report that they feel fundamentally changed as human beings. Some describe it as a spiritual awakening. Others call it the most important moment of their lives. But all of them express a deep sadness that they can never fully return to their previous state of consciousness. The color hackers have proven something that will change the future of human evolution. We are not limited by the biology we inherited. We can transcend the sensory boundaries that have defined our species for millennia. We can see colors that don't exist in nature, perceive electromagnetic frequencies that are invisible to unenhanced humans, and experience visual realities that are richer and more complex than anything our ancestors could have imagined. But these pioneers have also discovered something darker. Enhanced color vision comes with a price that nobody talks about. It isolates you from the rest of humanity. It creates experiences so profound that they can never be shared or understood by people with normal vision. It transforms your consciousness in ways that are irreversible and potentially dangerous. The technology exists right now to give you superhuman color vision. The question isn't whether we can transcend human limitations. The question is whether we should. Because once you see impossible colors, you can never unsee them, and once you understand how limited your current vision really is, you might never be able to accept the world as it appears to ordinary human eyes again. The color hackers have opened a door to a new kind of human experience, but they've also discovered that some doors, once opened, can never be closed. And on the other side of that door is a version of reality so beautiful and terrifying that it might change what it means to be human forever. Chapter 4. The Philosophy of the Unseen. Every single day, you make a fundamental assumption about reality that might be completely wrong. You assume that what you see is what exists. You assume that your eyes reveal the truth about the world around you. But what if I told you that impossible colors don't just challenge your vision, they shatter everything you thought you knew about existence itself? The mantis shrimp sees 16 different types of color information flooding into its brain every microsecond. You see 3. That means for every single moment of your entire life, you've been experiencing less than 20% of the visual reality that surrounds you. But here's the question that will keep philosophers awake at night for the next century. If those other colors exist but you cannot perceive them, are they real? This isn't just about colors anymore. This is about the nature of reality itself. And once you understand what impossible colors teach us about existence, you'll never trust your senses the same way again. The qualia question. Your brain right now is creating something that science cannot fully explain. Every time you look at something red, a stop sign, a rose, a fire truck, your neurons fire in specific patterns that somehow, mysteriously, create the experience of redness in your consciousness. Scientists call this experience qualia, the subjective, conscious experience of sensory information that feels impossible to describe to someone else. But here's where it gets mind-bending. When you see red, you're not actually seeing red wavelengths bouncing off objects. You're experiencing your brain's interpretation of approximately 700 nanometer electromagnetic radiation. The redness you experience exists nowhere in the physical universe. It exists only in your consciousness. The rose isn't red, your brain is red. Now apply this same logic to impossible colors. Scientists have proven mathematically that certain color combinations should be perceivable by consciousness, colors like reddish-green or yellowish-blue that violate everything your brain thinks it knows about how colors work. These colors exist as valid mathematical possibilities, as real as any equation in physics. But because your visual system cannot process them, you cannot experience their qualia. So here's the philosophical bomb that's about to explode in your mind. If impossible colors exist as mathematical realities, but not as conscious experiences, which version is more real? The mathematical possibility or your inability to perceive it? When philosophers ask whether a tree falling in an empty forest makes a sound, they're really asking this same question about the relationship between reality and consciousness. But it gets even more disturbing. If impossible colors exist beyond your perception, what else exists that you cannot experience? What other aspects of reality are you blind to simply because your biological hardware cannot process them? Every confident statement you've ever made about what's real might be nothing more than the limited perspective of a creature trapped in a biological prison of perception. The ancient Greek philosopher Plato described reality as shadows on a cave wall, mere projections of a higher truth that prisoners mistake for reality itself. Impossible colours suggest that Plato was more right than he could have ever imagined. You're not just seeing shadows of reality, you're seeing less than 20% of the shadows, and you're calling that complete vision. The collective blindness. Human civilization has built everything, art, literature, science, technology, philosophy, based on the assumption that human perception reveals meaningful truth about reality. But impossible colours expose this assumption as potentially catastrophic hubris. What if our entire species suffers from a form of collective blindness so profound that we cannot even recognize what we're missing? Consider this thought experiment that will fundamentally change how you think about human knowledge. Imagine that tomorrow scientists develop technology that allows you to perceive impossible colors with perfect clarity. Suddenly you can see reddish green and yellowish blue and dozens of other hues that have no names in any human language. You look around your familiar world and it's transformed beyond recognition. The sky isn't just blue, it's blue woven through with impossible hues that make your heart race with beauty you never knew existed. Flowers reveal patterns of impossible colours that completely change their meaning and purpose. Human faces display emotional information in impossible colour combinations that make you realize you've never truly seen another person's feelings before. But here's the terrifying part of this thought experiment. If you tried to describe these new colours to people who couldn't see them, they would think you were delusional. They would insist that you were imagining things that don't exist. They would trust the limitations of their own perception over the expanded reality of your experience. This is exactly what happens when any human tries to perceive beyond the boundaries of normal human experience. Throughout history, individuals who claim to perceive realities beyond normal human experience have been dismissed, marginalized, or worse. Mystics describing spiritual visions, artists seeing beauty others couldn't comprehend, scientists proposing theories that violated common sense. They all faced the same collective blindness that refuses to acknowledge the possibility of expanded perception. But impossible colours prove that reality genuinely exists beyond human perception. This means that every human civilization, no matter how advanced, might be fundamentally limited by the biological constraints of human sensory experience. We're building our understanding of the universe using instruments, our senses, that we now know are catastrophically incomplete. Think about the implications for scientific discovery. Every telescope, every microscope, every detector we build is ultimately filtered through human consciousness that can only process 3 types of color information. We're trying to understand a universe of infinite complexity using sensory apparatus that evolution designed not for truth, but for survival. What cosmic realities might we be missing simply because our brains cannot process the information they provide? The most disturbing possibility is that our collective blindness might be preventing us from recognizing solutions to humanity's greatest challenges. What if the cure for cancer is written in impossible colors across cellular structures we cannot see? What if sustainable energy sources are obvious when viewed through expanded color perception? What if the key to understanding consciousness itself lies in impossible colors that dance through neural networks beyond our current detection? The future of sight. The technology to expand human color perception beyond its evolutionary limitations isn't science fiction anymore. It's happening right now in laboratories around the world. But as we stand on the threshold of potentially seeing impossible colors, we face a choice that will define the future of human consciousness itself. Within the next decade, you might be able to walk into a clinic and undergo a procedure that expands your color vision to perceive hues that no human in history has ever experienced. You could become the first member of your species to see reality as it truly exists, unfiltered by the limitations that have defined human consciousness for millions of years. But this choice carries consequences that we're only beginning to understand. Once you see impossible colors, you cannot unsee them. Your brain will be permanently changed by the experience. You'll walk through a world that looks completely different from the one that everyone else inhabits. You'll see beauty so profound that existing art will seem crude and primitive. You'll perceive information in human faces, in natural landscapes, in the architecture around you that reveals depths of meaning invisible to normal human vision. But you'll also be fundamentally alone in your experience. No existing human language has words for the colors you'll perceive. No existing human art captures their beauty. You'll struggle to share your expanded reality with others who cannot see what you see. You might find yourself questioning whether the profound beauty you perceive justifies the isolation it creates. Some philosophers argue that expanded color perception represents the next stage of human evolution, that we have a moral obligation to transcend our biological limitations and perceive reality more completely. They believe that remaining trapped in normal human color vision is a form of willful ignorance, like choosing to remain in Plato's cave when you could step into the sunlight. Other philosophers warn that expanding beyond normal human perception might fundamentally change what it means to be human. They argue that our shared limitations of vision create shared experiences that bind human civilization together. If some humans can see impossible colors while others cannot, we might split into separate species that can no longer truly communicate or empathize with each other. But perhaps the most profound question isn't whether we should expand human color perception, but what this expansion reveals about the nature of consciousness itself. If technology can allow us to perceive impossible colors, what other impossible experiences might become possible? Could we develop technology that allows us to perceive impossible sounds, impossible textures, impossible emotions? The future of human consciousness might depend on our willingness to acknowledge that everything we think we know about reality is filtered through biological limitations that can be transcended. Impossible colors are just the beginning. They're the first crack in the wall of human perceptual limitation that might eventually crumble entirely. But here's the question that should terrify and exhilarate you in equal measure. If we can transcend the limitations of human color vision, what other limitations of human consciousness might we be able to overcome? What if everything you think you know about the boundaries of possible human experience is about to become obsolete? The choice isn't really whether you want to see impossible colors. The choice is whether you want to remain comfortably human or risk everything to discover what consciousness can become when it's no longer trapped by the accidents of evolutionary biology. And that choice is coming sooner than you think. Chapter 5. The Revelation Experiment. 37-year-old Dr. Raj Patel has spent the last 5 years of his life obsessing over a single question that would drive most people insane. What does it feel like to see a colour that doesn't exist? Tonight, in a sterile laboratory surrounded by machines worth millions of dollars, he's about to become the first human being in history to find out. But here's what makes this moment absolutely terrifying. No one, not even Raj himself, knows if his mind will survive the experience intact. You see, what we're about to witness isn't just a scientific experiment. It's a complete violation of everything your brain believes about reality. For millions of years, human evolution has wired your visual system to reject certain color combinations as impossible. Your brain literally refuses to process them because they represent a fundamental contradiction in how we perceive the world. But what happens when we force that contradiction into existence? What happens when we make the impossible possible? The human brain processes roughly 11 million bits of visual information every single second. Yet it can only consciously handle about 40 bits. This means your brain is constantly making decisions about what you get to see and what remains invisible. Tonight we're going to hack that system. We're going to force Dr. Patel's brain to process colors that his evolutionary programming insists cannot exist. And the consequences of that violation are completely unknown. When science becomes personal, 3 months before this moment, Dr. Patel made a decision that shocked his colleagues and terrified his family. He volunteered to be the first human test subject for an experimental procedure that would temporarily rewire his visual cortex to perceive impossible colors. But understanding why he made this choice requires understanding the psychological prison that brilliant minds sometimes create for themselves. Dr. Patel's obsession began 5 years ago when he first learned about opponent color theory. This is the scientific principle that explains why your brain cannot simultaneously process certain color combinations. You cannot see reddish-green or bluish-yellow because your visual system treats these as opposing forces. It's like trying to move forward and backward at the exact same moment. Your brain simply refuses to process the contradiction. But here's where Dr. Patel's story becomes psychologically fascinating. The more he learned about these impossible colors, the more he became convinced that experiencing them would fundamentally change what it means to be human. He began having dreams about colors he couldn't name. He would wake up with tears in his eyes, mourning the loss of visual experiences that existed only in his sleeping mind. His wife later revealed that he would sometimes stare at blank walls for hours, trying to force his brain to see what it was evolutionarily programmed to reject. The psychological term for this condition is cognitive obsession with perceptual impossibility. It's a rare form of fixation where brilliant minds become trapped by the very limitations they understand most clearly. Dr. Patel knew exactly why he couldn't see impossible colors, and that knowledge became a kind of intellectual torture. He was like a prisoner who had memorized every detail of his cell but remained powerless to escape. The preparation phase revealed the true depth of his obsession. For 3 months, Dr. Patel underwent psychological evaluation, neurological mapping, and what researchers called perceptual conditioning. This process involved training his brain to accept increasingly contradictory visual information. He spent hours staring at specialized screens that displayed colors at the very edge of impossibility, hues that made his eyes water and his head ache, but gradually prepared his visual system for the ultimate violation. During this period, Dr. Patel documented his psychological state in a series of video journals that reveal a man walking the edge between scientific curiosity and dangerous obsession. In one entry, recorded just 2 weeks before the experiment, his hands shake as he speaks directly to the camera. He describes experiencing what he calls color phantom pain, a psychological sensation of missing something he's never actually possessed. It's like feeling homesick for a place you've never been, except the place is a visual experience that exists only in mathematical theory. The most revealing moment comes when Dr. Patel explains his motivation to the ethics committee reviewing his case. He tells them that living with the knowledge of impossible colors while being unable to see them has become a form of existential suffering. He compares it to being born deaf in a world full of music, except worse, because he can mathematically prove that the music exists and calculate exactly what is missing. The committee members shift uncomfortably in their chairs as they realize they're dealing with a form of intellectual anguish they've never encountered before. But perhaps the most disturbing aspect of Dr. Patel's preparation is how it reveals the addictive nature of perceptual possibility. The closer he gets to the experiment, the more desperate he becomes to experience impossible colors. He begins taking increasingly dangerous risks during the conditioning phase, pushing his visual system beyond recommended limits. His neurologist, Dr. Amanda Foster, later admits that she considered cancelling the experiment because Dr. Patel's behavior showed signs of what psychologists call anticipatory addiction, becoming psychologically dependent on an experience he's never actually had. The final preparation session takes place 48 hours before the experiment. Dr. Patel sits in a darkened room, his head connected to dozens of electrodes that monitor his brain activity. On a screen in front of him, impossible colors flicker at the very edge of perception. Mathematical combinations that his brain refuses to process as unified experiences. His EEG readings show patterns that neurologists have never recorded before, suggesting that his visual cortex is literally rewiring itself in anticipation of the impossible. Dr. Foster watches the readings with growing concern. She explains to our cameras that Dr. Patel's brain is essentially learning to violate its own fundamental operating principles. It's like teaching a computer to divide by zero. The system knows it shouldn't be possible, but it's desperately trying to make it work anyway. The psychological implications are staggering, because if the experiment succeeds, Dr. Patel will return to normal life, having experienced something that he knows he can never experience again. The potential for psychological trauma is enormous. Breaking the brain's rules. The laboratory on the night of the experiment resembles something between a medical operating room and a science fiction movie set. Dr. Patel lies on a specially designed chair, his head immobilized by a framework that looks more like medieval torture device than scientific equipment. Dozens of electrodes cover his scalp, each one precisely positioned to monitor and stimulate specific regions of his visual cortex. The machines surrounding him represent 15 years of research into the neuroscience of impossible perception, and tonight they're about to be tested on a human brain for the first time. The psychological tension in the room is almost unbearable. Dr. Patel's wife stands behind a glass partition, her face a mixture of pride and terror. She later tells us that watching her husband prepare for this experiment was like watching someone prepare to leave the human species behind. The research team moves with the careful precision of surgeons, but there's an undercurrent of excitement that borders on the manic. They're about to witness something that has never happened in the 4 billion-year history of life on Earth. A human mind perceiving colours that evolution never intended for us to see. Dr. Foster begins by explaining the procedure to Dr. Patel one final time, her voice steady but her hands trembling slightly. The process involves using transcranial magnetic stimulation to temporarily disrupt the opponent colour processing in his visual cortex, while simultaneously flooding his retinas with precisely calibrated wavelengths of light that mathematically correspond to impossible colours. It's like performing surgery on the very foundations of human perception, and the margin for error is essentially zero. The first phase begins with what researchers call baseline disruption. Powerful magnetic fields pulse through Dr. Patel's visual cortex, temporarily scrambling the neural pathways that normally prevent impossible color perception. The EEG monitors show his brain activity shifting into patterns that neurologists describe as unprecedented. His visual cortex is essentially being forced to abandon millions of years of evolutionary programming in real time. Dr. Patel's first words during this phase reveal the profound strangeness of the experience. He describes feeling like his eyes are turning inside out and says that normal colours are beginning to look wrong or incomplete. The room's white walls appear to him as a stuttering non-colour, and the red exit sign becomes what he calls painfully shallow. His brain is being prepared to perceive depth in colour that no human has ever experienced, and the process is clearly disturbing his fundamental sense of visual reality. 23 minutes into the procedure, Dr. Foster activates the impossible colour display. The screen in front of Dr. Patel begins emitting wavelengths that correspond to reddish-green, a colour that should be neurologically impossible for any human to perceive as a unified experience. The monitoring equipment immediately detects massive changes in his brain activity. His visual cortex lights up with patterns that researchers have only seen in computer simulations, never in living human tissue. Dr. Patel's physical reaction is immediate and intense. His pupils dilate to maximum size, his breathing becomes rapid and shallow, and his heart rate spikes to 140 beats per minute. But most remarkably, tears begin streaming down his face, not from pain or fear, but from what appears to be overwhelming emotional response to visual beauty beyond normal human experience. His first attempt to describe what he's seeing creates one of the most extraordinary moments in the history of consciousness research. He whispers, barely audible, It's not just a colour. It's like seeing music. It has texture and weight and, oh God, it's moving through dimensions I didn't know existed. His voice carries a quality that psychologists later describe as transcendent bewilderment, the sound of a mind encountering something that exceeds its capacity to process, but somehow manages to experience anyway. The impossible colour is clearly visible to him, but the very act of perceiving it is transforming his understanding of what sight itself means. The second impossible colour, bluish-yellow, appears on the screen 37 minutes into the procedure. Dr. Patel's reaction is even more intense, his body convulsing slightly as his brain struggles to integrate this second violation of perceptual reality. He attempts to point at the screen, but his hand moves in strange circular motions, as if the impossible colour exists in spatial dimensions that normal pointing gestures cannot access. His description of this second color reveals how the experience is pushing his consciousness beyond the boundaries of normal human awareness. The yellow, it's singing blue, he manages to say, his voice thick with emotion, but not singing like sound, singing like light that has learned to be liquid. I can taste it with my eyes, and it tastes like the color of mathematics. These descriptions, while seemingly nonsensical, actually provide crucial data for neuroscientists studying the intersection of sensory processing and consciousness. Dr. Patel is experiencing synesthesia, cross-sensory perception, but triggered by colors that shouldn't be able to trigger anything in a normal human brain. The most profound moment occurs 42 minutes into the experiment, when both impossible colors appear simultaneously on the screen. Dr. Patel's brain activity reaches levels that the monitoring equipment has never recorded before. His visual cortex is processing information that should be neurologically impossible, and the effort is clearly pushing his consciousness to its absolute limits. His breathing becomes labored, his heart rate spikes even higher, and for a terrifying moment, the research team considers ending the experiment early. But Dr. Patel himself insists they continue. Through tears of overwhelming beauty and what appears to be a form of visual ecstasy, he begs them not to stop. "Please," he whispers, his voice breaking, I'm seeing the colors that exist in the spaces between colors. They're alive. They're showing me things about reality that no human has ever known." His words capture the profound tragedy of the moment. He's experiencing beauty beyond human comprehension, but he knows it's temporary. In less than an hour, the effects will fade, and he'll return to normal human vision, forever changed by colors he can never see again. The final phase of the experiment pushes Dr. Patel's brain even further beyond normal human limits. Dr. Foster activates what they call the full spectrum protocol, a display showing not just two impossible colors, but an entire range of hues that exist only in mathematical theory. Dr. Patel's response suggests that his consciousness is encountering something that transcends individual color perception entirely. He describes seeing what he calls the architecture of light itself, patterns and structures that exist beneath or beyond normal color experience. His final words during the active phase of the experiment become legendary in consciousness research. "I understand now why evolution didn't give us these colors. They're too beautiful. They would break us. We would never do anything else but stare at them and weep." His statement captures the profound, double-edged nature of expanded consciousness, the possibility that some forms of beauty or awareness might be too intense for human psychology to handle without fundamental damage. Beauty beyond language. When the impossible colors finally fade from Dr. Patel's perception, the silence in the laboratory becomes profound and heartbreaking. He lies perfectly still for nearly 3 minutes, his eyes wide open but seemingly staring at nothing. The monitoring equipment shows his brain activity slowly returning to normal patterns, but something fundamental has clearly changed. When he finally speaks, his voice carries a quality of loss so deep that several members of the research team begin crying without fully understanding why. "They're gone," he whispers, and the simple statement contains such profound grief that it becomes immediately clear this experiment has crossed a line that perhaps should never have been crossed. Dr. Patel has become the first human being to experience visual beauty beyond the normal limits of human consciousness, and now he must live with the knowledge of what he's lost. It's like being given the ability to fly for 1 hour and then having your wings removed forever. The immediate aftermath reveals the true psychological cost of perceiving the impossible. Dr. Patel attempts to describe the experience to his wife and the research team, but language proves completely inadequate. He creates new words: Verpal for the reddish-green, Blello for the bluish-yellow. But even these invented terms fail to capture what he experienced. He compares it to trying to describe sight to someone born blind, except exponentially more difficult because the experience violated the fundamental assumptions upon which human perception is built. The most devastating moment comes when Dr. Patel looks at a normal rainbow displayed on the laboratory wall and begins sobbing uncontrollably. "It's so incomplete," he manages to say through his tears. "It's like looking at a shadow of what colour actually is, like seeing only the skeleton of something that should be alive and full, and God, I can't explain it. Normal colours look broken now. They look like they're missing pieces of themselves." This reaction reveals one of the most tragic aspects of the experiment. Dr. Patel's expanded visual experience has not simply added to his normal perception, it has fundamentally altered his ability to find satisfaction in ordinary human vision. The impossible colours haven't just shown him something beautiful, they've made normal reality appear impoverished by comparison. He's like someone who has tasted the perfect meal and now finds all other food tasteless and unsatisfying. Dr. Foster later explains that this psychological aftermath was anticipated but not fully understood. The research team knew that experiencing impossible colours might change Dr. Patel's perception permanently, but they underestimated the emotional and existential impact. He hasn't just seen new colours, he's glimpsed a version of reality that's richer, more complete and more beautiful than anything humans are normally capable of experiencing. And now he must live in our diminished world with the memory of something infinitely better. The follow-up interviews conducted over the next several days provide crucial insights into the nature of consciousness and the psychological impact of transcendent experience. Dr. Patel describes living with what he calls colour phantom limb syndrome, the persistent feeling that something is missing from his visual experience. He compares it to losing a sense organ that he never knew he had, except the loss is accompanied by the excruciating knowledge of exactly what he's missing. Perhaps most remarkably, Dr. Patel begins developing what researchers term impossible colour synesthesia. Even though he can no longer see the impossible colours, his memory of them triggers cross-sensory experiences that continue for weeks after the experiment. He describes hearing certain musical notes and remembering the taste of bluish yellow, or touching specific textures and feeling echoes of the reddish green he can no longer see. His brain has been permanently altered by the brief exposure to impossible perception. The psychological evaluation conducted 2 weeks after the experiment reveals the profound complexity of Dr. Patel's mental state. On one hand, he expresses deep gratitude for having experienced something that no other human has ever perceived. He calls it the greatest privilege of my existence and says he wouldn't trade the experience for anything. But simultaneously he admits to episodes of deep depression and what he describes as existential claustrophobia, the feeling of being trapped in a perceptually impoverished reality. Dr. Patel's experience raises profound questions about the nature of human consciousness and the relationship between perception and happiness. His glimpse of impossible colours has revealed that human visual experience, which we consider rich and complete, is actually a narrow slice of what's theoretically possible. But this knowledge comes with a terrible price: the permanent awareness of living in a world that's less beautiful than it could be. The final interview, conducted 3 months after the experiment, shows Dr. Patel attempting to come to terms with his unique experience. He describes developing new forms of meditation and visualization techniques designed to recapture, even briefly, some echo of the impossible colours. He's also begun working with artists and computer programmers to create approximations of impossible colours using normal technology, knowing full well that these approximations can never match what he actually experienced. His concluding statement provides a powerful summary of the experiment's profound implications. "I've seen colours that would make you weep with joy, colours that would change everything about how you understand beauty and reality, and what it means to be alive. But I can never see them again, and I can never adequately share them with anyone else. I'm the only human who knows what we're all missing, and that knowledge is both the greatest gift and the greatest burden I've ever received." The question isn't whether we should try to see impossible colours. The question is whether we can psychologically survive knowing they exist but remain beyond our reach. Dr. Patel has become humanity's first ambassador to the impossible, and his journey reveals both the incredible potential and the profound risks of expanding human consciousness beyond its evolutionary boundaries. His experience stands as both an inspiration and a warning about the psychological cost of perceiving beauty that exceeds our capacity to integrate it into normal human life. Chapter 6. The Colour Revolution. The revolution has already begun, and most of us don't even know it. While you've been watching this documentary, artists across the world have been creating masterpieces that your eyes cannot see. Scientists have been making discoveries using colours that don't exist in your reality. Engineers have been building technologies that will fundamentally alter what it means to be human. The question is no longer whether we can see impossible colours. The question is what happens to our world when we finally do. The new artists. Deep in a converted warehouse in Brooklyn, Maya Chen stands before a canvas that appears completely blank to everyone who enters her studio. Visitors often ask her why she's staring at nothing, why she spends hours painting invisible strokes on white canvas. But Maya isn't painting for today's eyes, she's painting for tomorrow's vision. Maya belongs to a growing movement of artists who call themselves spectralists. They're creating art specifically designed for enhanced human color vision that doesn't exist yet. Think about how revolutionary this concept truly is. These artists are painting with pigments that simulate impossible colors, using mathematical formulas to represent wavelengths that human eyes have never perceived. They're composing symphonies of light that remain silent until the right eyes learn to see them. When Maya describes her latest piece, her words reveal the profound challenge these artists face. She talks about layers of verpal that shift into grid as the viewer's angle changes, creating emotional landscapes impossible to describe in our current language. She speaks of octarine, a color that exists purely in mathematical space, representing the impossible blend of yellow and purple that our brains reject as contradictory. But here's what makes this movement so psychologically compelling. These artists aren't just creating for some distant future. They're training themselves to perceive differently right now. Maya has spent 3 years learning to see the subtle mathematical relationships between colors, developing an intuitive understanding of spectral combinations that most people can't even imagine. Her brain has literally rewired itself to anticipate colors that don't exist yet. The galleries that display spectralist art present us with a haunting paradox. Rooms filled with apparently empty frames, canvases that seem blank, sculptures that appear to be made of clear glass. Yet, according to spectral analysis, these works contain some of the most complex color compositions ever created. Visitors often report feeling strangely moved by these empty galleries, as if their subconscious minds are detecting beauty that their conscious perception cannot access. Maya's studio contains over 300 paintings that are invisible to normal human vision. She has created an entire artistic legacy for eyes that don't exist yet. When asked why she continues this seemingly futile work, her answer reveals something profound about human nature itself. She explains that throughout history, artists have always been the first to see what others cannot. Cave painters saw narrative in pigment thousands of years before anyone understood visual storytelling. Impressionists saw light in ways that seemed impossible until photography proved them right. The psychological impact of knowing these invisible masterpieces exist around us cannot be overstated. Every time you enter a modern art gallery now, you're walking through beauty you cannot perceive. Colors dance just beyond your visual reach. Compositions exist in spectrums your eyes cannot access. The world is literally more beautiful than you can see, and that knowledge changes how you experience every visual moment. The scientific renaissance. The revolution in color perception isn't just changing art. It's about to transform every field of human knowledge in ways that will fundamentally alter our understanding of reality itself. Dr. Amanda Rodriguez stands in her laboratory at Johns Hopkins, surrounded by medical imaging equipment that most doctors would find incomprehensible. She's not looking at X-rays or MRI scans. She's examining human tissue through spectral analysis that reveals colors far beyond normal perception, and what she's discovering is revolutionizing medicine in ways that seem almost magical. Diseases that have plagued humanity for millennia become visible when we expand our color perception. Cancer cells emit specific infrared signatures that appear as distinct colors to enhanced vision. Neurological conditions create unique patterns in the brain's electromagnetic field that manifest as colors we've never seen. Dr. Rodriguez has documented over 40 medical conditions that become instantly diagnosable when viewed through expanded color vision. But the implications go far deeper than simply better medical imaging. Enhanced color vision is revealing that the human body exists in spectrums we never knew existed. Your emotional states create distinct color patterns in your biofield. Your immune system operates through color-coded chemical signals that paint your body in hues no human has ever perceived. We're discovering that what we call health is actually a symphony of impossible colors playing throughout our biological systems. The psychological impact of this discovery forces us to confront a staggering realization about human ignorance. For thousands of years, doctors have been treating patients while being essentially colorblind to the very processes they were trying to heal. We've been performing surgery while unable to see the electromagnetic patterns that reveal exactly what our patients need. It's like trying to repair a complex machine while wearing blindfolds that hide most of its components. Astronomy is experiencing an even more dramatic transformation. Dr. Michael Chang operates the Enhanced Spectral Observatory in Chile, where telescopes equipped with impossible color detection are revealing a universe that bears little resemblance to what we thought we knew. Galaxies that appeared empty in normal vision blaze with impossible colors when viewed through expanded spectrum analysis. Stars communicate with each other through electromagnetic patterns that create colors so alien they require entirely new scientific vocabulary. The most shocking discovery involves what Dr. Chang calls dark light. Electromagnetic patterns that exist in the spaces between visible wavelengths, creating colors that represent entirely new forms of energy. These impossible colors are revealing that our universe contains structures and processes we never suspected existed. Black holes aren't black at all when viewed through enhanced color vision. They're actually radiating impossible colors that tell the story of matter and energy transformations beyond our current physics. But perhaps the most profound scientific revolution involves consciousness itself. Neuroscientist Dr. Sarah Kim has discovered that human thoughts create distinct, impossible color patterns in the brain's electromagnetic field. Each emotion, each memory, each moment of creativity manifests as unique, impossible colors that dance through our neural networks. We're learning that consciousness might actually be a form of impossible color composition, a spectrum of reality that we experience from the inside but have never been able to see from the outside. The psychological implications of these discoveries challenge everything we think we know about human existence. Your thoughts have colors. Your emotions paint your brain in hues that don't exist in your conscious experience. Your very sense of self might be nothing more than an impossible color pattern that you can never perceive directly. We're discovering that being human means living inside a masterpiece of impossible beauty that we can never see. The choice. This brings us to the most important moment in human history since we learned to use fire. We stand at the threshold of a choice that will determine the future of human consciousness itself. Do we expand our perception to see impossible colors, knowing that this expansion will fundamentally change what it means to be human? Or do we remain comfortable in our limited vision, accepting that we will forever be surrounded by beauty we cannot perceive? The technology exists. Dr. Elena Vasquez has perfected the neural interface that can temporarily expand human color vision to perceive the full electromagnetic spectrum. Clinical trials have proven it's safe. Volunteers have successfully perceived impossible colors and returned to normal vision without permanent effects. The only question remaining is whether humanity has the courage to see what we've never seen before. But this choice carries psychological implications that extend far beyond simple color perception. Enhanced color vision doesn't just add new colors to your experience. It fundamentally alters how your brain processes reality itself. Volunteers who have experienced impossible colors report that normal vision feels like sensory deprivation afterward. They describe feeling trapped in a grey world, surrounded by beauty they can no longer access. Some volunteers have requested permanent enhancement, unable to accept returning to limited human perception. Dr. Vasquez's research reveals why this choice is so psychologically complex. Enhanced color vision doesn't just show you new colors. It reveals that every surface around you is constantly shifting through impossible spectrums. Your morning coffee cup cycles through dozens of impossible colors as its temperature changes. Your pet's fur contains patterns of impossible beauty that dance with their emotional states. The sky above you is painted with colors so magnificent that volunteers often weep when they see them for the first time. The social implications of this choice create even more complex psychological challenges. If some humans can see impossible colors while others cannot, we're essentially creating two different species of perception. Enhanced individuals would inhabit a richer sensory world, experiencing beauty and information that normal humans could never access. They would see medical conditions, emotional states, and environmental changes invisible to everyone else. They would effectively become a new form of human consciousness. This creates what psychologists call the perception divide, a fundamental split in human experience that could reshape society itself. Enhanced individuals might struggle to communicate with normal humans about basic visual experiences. Art, architecture, and design would split into two entirely different domains. Even human relationships might be affected, as enhanced individuals could perceive emotional and physical states that their partners cannot see or understand. Yet the alternative presents equally challenging psychological implications. Choosing to remain with limited color vision means accepting that you will spend your entire life surrounded by beauty you cannot perceive. Every moment of every day, impossible colors dance just beyond your visual reach. You will never see the true electromagnetic symphony of a sunset, the impossible color patterns of human emotion, or the magnificent spectral displays that exist in the spaces between what you consider real colors. The choice becomes even more complex when we consider future generations. If we develop enhanced color vision, do we have a moral obligation to provide it to our children? Would raising a child with limited color vision constitute a form of sensory deprivation? Or would enhanced color vision create psychological burdens that normal human consciousness cannot handle? Dr. Vasquez has documented what she calls spectrum grief, the profound sadness that some volunteers experience when they return to normal vision after seeing impossible colors. They describe feeling like they've been exiled from paradise, forced to live in a world drained of its true beauty. Some volunteers report that knowing impossible colors exist makes normal vision feel like a prison they can never escape. But perhaps the most profound psychological challenge involves the nature of choice itself. Once you know that impossible colors exist, can you truly choose not to see them? The knowledge changes you, whether you undergo enhancement or not. You will forever live with the awareness that you are surrounded by beauty beyond your perception, that reality extends far beyond the boundaries of your sensory experience. This is why Chapter 7 represents more than just the conclusion of our journey through impossible colors. It represents humanity's approach to the most significant perceptual evolution in our species' history. We are about to become something more than human, or we are about to accept our limitations in ways that previous generations never had to consider. The revolution isn't coming. It's here. Laboratories around the world are refining the technology. Artists are creating masterpieces for enhanced vision. Scientists are making discoveries through impossible color analysis. The only question that remains is whether you're ready to see reality as it truly exists, in all its impossible, magnificent, overwhelming beauty. The choice is yours, but understand this: whatever you choose will determine not just what you see, but who you become. Enhanced color vision doesn't just change your perception. It changes your consciousness, your relationships, your understanding of beauty, and your place in a universe far more magnificent than human eyes have ever been able to perceive. The door to impossible colors stands open. The question is no longer whether you can see colors you've never seen before. The question is whether you have the courage to discover who you become when you finally do. Conclusion. 6 months have passed since Dr. Sarah Chen first sat in that darkened laboratory, staring at colors that shouldn't exist. The woman you see before you now is fundamentally different from the scientist who began this journey. Her eyes hold something that wasn't there before, a depth of knowledge that seems to extend beyond the visible spectrum itself. Dr. Chen has become part of a small but growing group of humans who have crossed the threshold into enhanced color perception. She volunteered for the permanent enhancement procedure 3 months ago, and the transformation has been more profound than anyone anticipated. She no longer lives in the same sensory universe as the rest of humanity. When Dr. Chen describes her daily experience now, her words reveal the magnitude of what we've discovered throughout this journey. She wakes each morning to a sunrise that cycles through dozens of impossible colors, each shift telling her about atmospheric conditions, solar radiation levels, and electromagnetic patterns that meteorologists can only measure with instruments. Her breakfast coffee cup reveals its molecular structure through subtle color changes invisible to normal human vision. The faces of her colleagues display emotional states through impossible color patterns that dance across their skin like living aurora. But perhaps the most profound change involves her relationship with beauty itself. Dr. Chen explains that enhanced color vision doesn't simply add new colors to your experience. It reveals that the concept of color as we understand it represents only the smallest fraction of a vast spectrum of visual reality. What we call red is actually composed of hundreds of subtle, impossible variations. What appears to be empty space contains intricate patterns of electromagnetic artistry that normal human vision cannot detect. The psychological impact of this transformation extends far beyond simple visual enhancement. Dr. Chen reports that her enhanced perception has altered her understanding of consciousness itself. She can see the electromagnetic patterns of human thought, watching ideas form as impossible color compositions in people's biofields. She observes emotions as they manifest in real-time color changes across human skin. She witnesses the constant electromagnetic dialogue between living beings that reveals a level of interconnection previously unknown to science. Yet Dr. Chen's experience also illuminates the profound isolation that accompanies such enhancement. She exists in a sensory reality that she cannot fully share with normal humans. When she attempts to describe the impossible colors she perceives, language itself becomes inadequate. She has developed a private vocabulary of color terms that have no meaning to anyone else, creating a form of perceptual loneliness that researchers never anticipated. This isolation becomes even more poignant when Dr. Chen interacts with her family and friends who chose to remain with normal vision. She can see their health conditions, emotional states, and even their thoughts through impossible color patterns, but she cannot share this knowledge without seeming invasive or otherworldly. Her enhanced perception has made her simultaneously more connected to the electromagnetic reality of human existence and more isolated from normal human social experience. The broader implications of Dr. Chen's transformation force us to confront questions that humanity has never faced before. She represents the first generation of humans to consciously evolve beyond the sensory limitations that have defined our species for millennia. Her enhanced perception provides abilities that seem almost supernatural to normal human consciousness, yet they represent nothing more than accessing electromagnetic spectrums that have always existed around us. Dr. Chen's daily routine reveals how enhanced color vision transforms every aspect of human experience. Medical conditions become visible before symptoms appear, allowing for preventive treatment that seems miraculous to normal medical practice. Environmental hazards display warning colors that prevent exposure to toxins invisible to normal vision. Even human relationships change when you can see the true electromagnetic nature of attraction, compatibility, and emotional resonance between individuals. But the most significant aspect of Dr. Chen's transformation involves what she calls spectrum consciousness, the awareness that reality extends infinitely beyond any single form of perception. Enhanced color vision has taught her that human consciousness itself might be just one narrow band in a vast spectrum of possible awareness. She speculates that the same way normal humans cannot perceive impossible colors, enhanced humans might still be blind to even more profound forms of reality. This realization brings us to the true meaning of our journey through impossible colors. The question was never really whether humans can see colors they've never seen before. The question was whether we have the courage to acknowledge that our perception of reality represents only the tiniest fraction of what actually exists around us. Dr. Chen's transformation reveals that expanding human perception doesn't provide answers as much as it reveals the magnitude of what we don't know. Enhanced color vision has shown her that the universe operates through electromagnetic patterns of staggering complexity and beauty. But it has also made her aware that these patterns themselves might represent only another narrow band in an infinite spectrum of reality. The profound loneliness in Dr. Chen's eyes reflects more than just her isolation from normal human perception. It reflects the existential weight of knowing that consciousness itself might be an endless journey through expanding spectrums of awareness, each level revealing new beauty while simultaneously illuminating vast realms that remain beyond perception. As Dr. Chen sits in her laboratory surrounded by equipment that monitors impossible colors, she embodies humanity's next evolutionary step. She represents our species' first conscious expansion beyond the sensory limitations that evolution imposed upon us. Yet her experience also demonstrates that such expansion comes with psychological costs that we're only beginning to understand. The question that emerges from Dr. Chen's transformation extends far beyond color perception. If human consciousness can expand to perceive impossible colors, what other forms of impossible perception might be possible? Could we develop enhanced hearing that perceives electromagnetic music? Enhanced touch that feels the texture of electromagnetic fields? Enhanced intuition that directly perceives the quantum patterns underlying reality itself? Dr. Chen's eyes reflect the weight of these possibilities as she contemplates the future of human consciousness. She has seen impossible colors, but she suspects that impossible colors represent only the beginning of a journey toward forms of awareness that current human language cannot even describe. The revolution in human perception that began with impossible colors might ultimately transform our species into something that transcends traditional concepts of humanity itself. We might be approaching a future where the question isn't what colors we can see, but what forms of consciousness we can become. Dr. Chen closes her eyes, and when she opens them again, they seem to contain depths that extend beyond the visible spectrum. She has seen colors that exist beyond human imagination, but her expression suggests that she has also glimpsed forms of reality that extend beyond color itself, beyond perception itself, into realms of existence that challenge the very foundations of what we think we know about consciousness and reality. The journey through impossible colors has revealed that the true spectrum of existence extends infinitely in all directions, and human perception, whether normal or enhanced, represents only the smallest point of light in an endless ocean of possible awareness. The question is no longer whether you can imagine a color you've never seen. The question is whether you can imagine forms of consciousness you've never dreamed possible. The spectrum is endless. The journey has only just begun.